So in this video, we are going to speak about two of the other types of analysis, that is RT analysis and time analysis. So RT analysis refers to runtime analysis. It simulates the circuit in real time in a separate window. The compiler keeps track of CPU time. The node voltages can be set during simulation using scan command in the shell window. Now this is a very important point, that is the node voltages can be set during simulation using scan in the shell window. That is, we can give input values after the simulation has started, and after we have given input values it will automatically change the output values in real time according to the real time inputs. The initial node voltage values can be set either using fixed voltage or main circuit setup construct. Has uses for both combinational as well as sequential circuits. To exit the simulation, press enter without entering any value. Now you cannot use print and plot together. If used, only printing takes place. So if we use print and plot together in case of RT analysis, then only printing takes place, and it does not take any argument. As you can see, the syntax is pretty much similar to OT analysis as we had discussed in the other video, and so OT analysis, it didn't have arguments. Similarly, its RT analysis does not take any arguments after this. So this is an example code which has been given here, and okay. So the above figure shows how the scan cycle takes place during real-time simulation. As you can see in the figure that it is scanning in real time. Okay, and this shows a real time plot. Okay. So now, what is time analysis? Now, time analysis. This analysis lets us carry out the simulation over a fixed time interval or in real time, but no changes can be made in the circuit in real time. So this is essentially the difference between RT analysis and time analysis. That is, no input. In case of time analysis, we cannot make any changes to the voltages in real time. While in the case of real time analysis, we can change the voltages in real time depending upon the real time inputs, and scan cannot be used in this type of analysis type because we cannot change the values after the simulation has started. So it allows two variations: real time analysis and finite time analysis. In real time analysis, simulation takes place in real time and results are displayed while the simulation is still running. Print prints the node voltages in real time. Plot animates the node voltages with time. To exit the simulation, you have to press enter. So this is the syntax NVN CKT time analysis. The syntax of real-time analysis and finite time analysis basically differs by this time parameter, which is given in milliseconds, and the simulation takes place for a finite amount of time. The results of the simulation are displayed after the simulation ends. Print and plot displays at the end of the simulation. The simulation time needs to be mentioned in milliseconds after analysis time. So this is an example which is given in documentation about 4-bit up counter. So now let us see an example which I have written. I had already opened my command prompt window. Okay, so let us see. Okay, so this is my code, and I am working with a T flip-flop. I'm working with a T flip-flop, and it has the clock input, and it has T value. This is Q and this is Q bar, and I am fixing the value of node 1 with 1 logic level, and I'm giving a clock at the clock input, and my time analysis, I'm working with time analysis, finite time analysis, and it works for 3000 milliseconds. So let us see. Let's plot and see what happens. Okay, so time analysis has been performed, and we'll see what happens. So as I have plotted it, or my plot has been generated for 3000 milliseconds. As you can see, it has been for 3000 milliseconds. So the basic functioning of a T flip-flop, it works in this way that at each negative edge, that is whenever the input clock goes from positive 1 or from logic level 1 to logic level 0, then it undergoes a toggle. That is, the q n minus 1 value changes to q n minus 1 n minus 1 complement. That is, qn is equals to qn minus 1 complement. The previous voltage state is just complemented, and this is my q bar value. And so that's how time analysis works for a finite time interval.